place block functionality is probably the funnest part of the project. It's where everything comes together to make an actual playable block game. Our objectives for this module are to create a custom event to place blocks. We'll apply world location and a forward vector to establish beginning and ending locations in 3D world space, utilizing a very important bit of functionality called a line trace. Finally, we'll write code to create blocks at the location the player clicked on. To get started, let's open up the BP block player. We're going to need a variable that tells us the maximum distance will allow a player to click to add a block. Click on the Add Variable button and name the new variable furthest distance to click. Change the variable type to a float. Click Compile and set the default value to 1000. That'll mean 10 blocks away from the player. Now we're going to need to write 2 pieces of support code before we get to the point where we can actually place down blocks. The first is a function to determine where the crosshair is pointing in 3D space. The second is a timeline that we'll use to rotate the player so they're facing the spot where the click occurred. Let's write the function first. Click the Add Function button and name the new function getCrosshairLocation. Add an output called crosshairLocation of type vector. Click the new parameter in the output section, change the name to crosshairLocation, and change the type to type vector. What we're essentially doing here is converting the XY value of the crosshair to a point in 3D space. To write this function, we'll need to get the crosshair and retrieve the crosshair X and Y value from the crosshair. So drag off of the crosshair and type in crosshair, get crosshair X, and crosshair Y. Next, we'll need the player controller variable. And from the player controller variable, drag that out and type in dProject screen to world. This node takes in a screen position and outputs a world position and direction. Perfect. The screen position is a point structure, a vector 2D structure. Let's right-click on it and split the structure pin. Connect the crosshair X to position X, crosshair Y to position Y. I'm going to move all of this over. We'll take the world direction and we need to add to that the direction that the camera is pointing and the distance that the camera is back. So we'll need the spring arm, and from the spring arm, we'll get the target arm length, and then we'll add that to the furthest distance to click variable. So get that, drag that out, and from the furthest distance to click, add a plus float. Hook those together. So this is to account for the fact that the camera is actually back a certain distance. And from the world direction, we're going to drag out of that, type times, and we want to multiply that world direction times a float. We'll take the world position, add that, and that's going to be a vector plus vector. The second vector is the product of this multiplication. And that will be the crosshair location that the player clicked on in 3D space that will be returned as a vector. Click Compile and save. The getCrosshairLocation function uses some pretty straightforward math to figure out where the crosshair is in 3D space. It's useful to break it down and learn how it works because you can apply these concepts in other scenarios in your game programming. The getCrosshairLocation takes the location of the crosshair in 2D space as it's projected on the camera face. So that would be a location about right where my mouse is right now. That returns the crosshair X and Y, and it sets the screen position X and Y in the call to the dproject screen to world. The dproject screen to world returns the world position of the camera face, or the crosshair on the camera face, and the world direction as a normalized vector, which we'll see in just a second why that's useful. In this example, the camera is pointing forward in the x-axis. The normalized world direction would be 1, 0, 0. The target arm length of the spring arm that we retrieve from the spring arm right here is 300, usually, unless we've zoomed in or out. And the furthest distance to click variable is set by default to 1,000. We add those two together and come up with 1,300. We then multiply the vector that's the world direction by that distance. And the reason we use the furthest distance to click and add to it is because we want to click somewhere out here. So we multiply 1,300 times that world direction, and we come up with 1,300, 0, and 0. The product of that multiplication is then added to the world position of where the camera was. So if the player is at 200, 400, 100, or more accurately, if the camera is at that location, we then add the product that we just calculated below to that. So we add 1,300, 0, and 0 to it, come up with a location of 1,500 in the X, 400 in the Y, and 100 in the Z, out here somewhere. Now, just looking at the nodes and running the numbers by is all well and good. It would help to see this in the engine. What I've done is I've taken the get crosshair location function and duplicated it and made a debug version of it. That's right here. This version is identical to the get crosshair location function, except I've added a line trace, a topic that we'll be covering soon enough. The line trace has the ability to draw a line from the start location and the end location of the line trace, and that's going to be really useful for us. I've set up the BP block player so when we left click to simulate placing a block, it will call the get crosshair location debug function. Again, this will make more sense when you start adding the ability to add blocks, but I wanted to show this example before we got to that. Another change I made in the BP block player is that I changed the camera so that the mesh won't be hidden in the game, so that we'll actually see the camera mesh. Over in the block game map, I'm going to play the game. I'm going to move the camera up so it's pointing to a location just in front of us, and I'm going to left click. And you could see the line trace was made there. Now I'm going to press F8 to eject from the player and move out of the way here so that you can see the camera and see the line trace that occurred. So this is the location where the crosshair was calculated. This is roughly our spring arm length plus the 1,000 units. Adding all of that in the direction that the camera was facing lands just in front of us perfectly. I hope that helps you understand the code that's in the get crosshair location function. Close the get crosshair location function and find a nice blank spot to add some code. We're going to put the second piece of this together, and that's going to be a timeline that's going to rotate the player to face where the block is added. So right click and type in add timeline and name this timeline rotate timeline. Double click on the timeline and then add a float track. Name the track alpha. Set the length of the timeline to 0.2 seconds. Shift left click at the 0 mark to add a keyframe, and you can edit that. So go up and set the time to 0 and the value to 0 if it wasn't set correctly. And then shift left click over at the end and make sure the time is set to 0.2 seconds and set the value to 1. So this value is going to go from 0 to 1 in 0.2 seconds. And you can Click the zoom to fit horizontal and zoom to fit vertical so you can get a better view of that. Go ahead and close out of the timeline, and we're going to need two variables that we're going to change from one to the other, and they're going to be rotations. One will be the current rotation, or the rotation that the character has, and the other will be the target rotation, the rotation of where we want it to be pointing. So let's add those variables. Click the Add Variable button and call this current rotation, and we're going to set these later. So don't worry that we haven't set them yet. And we want to change that type to a rotator. And click Add Variable again. And this is going to be the target rotation. That should already be a rotator. And go ahead and just click Compile. Again, we'll set these values before we use the timeline. So let's get the current rotation and get the target rotation. And we'll use the alpha value to interpolate between the two, and we'll use what's called a lerp for a rotator. So drag out of the current rotation and type in lerp for linear interpolation, and set the target rotation as B. So current rotation's A, target rotation's B. Alpha is how far between A and B we are, and at 0 we'll be on A, and on when alpha is 1 we'll be at B. So we'll use the alpha value to go between the two. And in the update of the timeline, we'll drag off of that. And we'll type in set actor rotation. Now we don't want to set the entire rotation. We just want to rotate around the z-axis. So we're going to split the return value, split structure pin, and just get the yaw and right-click on the new rotation and split that structure pin. We'll zero out the X and Y and just use the yaw for that. And let's select all of that, move it over a little bit, press C to add a comment, timeline for rotating before placing block. And that's it for the timeline. All right, so now we're ready to add the functionality to add a block. Let's find a nice open area in the event graph to get some room to write some code. And right-click and type in place block to get the action event place block. And what we're going to do is we're going to do this in several steps. We're going to write a custom event to actually place the block and have a timer that's called when the place block event occurs. So in other words, when they left click. So let's right click and type in add custom event and name this place block down. Drag off of the pressed execution wire and type in set timer by event. Set the time to 0.2 seconds, and we want that to loop. Hook up the event delegate to the place block down. Now, we also have to call this directly, otherwise it'll be a delay. There will be a delay of 0.2 seconds. So drag off of the set timer by event and type in place block down to call that immediately so we can start placing blocks. Now, one very important thing we have to do here is stop calling this when we release the left mouse button or whatever button we've assigned to place blocks. So off of the released execution pin, type in clear timer by function name, and the function name that goes here has to match the function name for the custom event. So to make sure that's correct, what I do is I select the custom event, press F2 as if I were going to rename it, Control C to copy, click here in function name and Control V to paste, and that avoids any possible typos. So we are all set, and we just have to write the code to actually place the block down. So to do that, we're going to first rotate the character in the proper direction, and we'll do that by right-clicking and calling get actor rotation, and we'll use that to assign the current rotation. So do a set on current rotation, look that up, and the current rotation of the actor is now set. Then we'll get the actor's location, right click, get actor location. And from that, we'll find what direction they are looking. So drag off of that, find, look at rotation. And then we'll use our get crosshair location function. So we'll have to call that, and that will return the crosshair location. And we'll use that to set the value of the target rotation. So drag out the target rotation, and we're going to do a set on that. And hook up that execution pin. Now that we've set our current rotation and our target rotation, we can use the timeline that we created earlier to rotate the player to that location. If you open up the components and the variables, you'll see that the rotate timeline is a variable that you can get. Drag that out, get it, and now we can call functions on that timeline. So from the rotate timeline, drag that out and type in play from start. That will play the timeline for us, rotating between the current rotation and the target rotation. Drag off of that, and we need to now figure out what block we clicked on. And we don't have a function for that yet. We have to write it. So that's the next step. Click on the add function and type in get clicked on block. The get clicked on block function has to do a bit of work to figure out what block was clicked on. It's going to need some information to know where its target is, and it's going to return that back as a block that was clicked on or the fact that a block wasn't clicked on. So we'll use inputs and outputs for that. For the input, we're going to add a new input parameter. So click on new input and name that target, and that should be a vector. And if you don't have that, then change the type to vector. The outputs for this function are going to be whether or not the hit was a success, where the location was, what the normal was, the direction the block was facing, and the block that was actually hit. So click on new parameter, and for output, new parameter, and we're going to name this one hit success. That's going to be a Boolean, true or false. Did we hit something successfully? Click new parameter, and we're going to name this one location. Where did the hit occurred? That should be a vector. And new output parameter again. And the normal, what direction was the face facing that was hit? And that's a vector as well. Finally, we'll click new parameter and hit block. If hit success was true, hit block will be set to a reference to the block that was hit. So we're going to change the type of that to a BP base block. Now, because we're using inheritance, we can use a BP base block and return the BP base block that was hit, no matter what kind of block was hit. A child class of a BP base block could be hit. It can still be a BP base block because inheritance supports that. So there's our return node for that. Now we're going to need a second return node in the event that hit success was false. And you'll see why when we write this function. So I'm just going to select the return node and hit Control W to duplicate that. And we'll get to that part in just a couple of minutes here. So what we're going to perform is what's called a line trace. And a line trace needs to know where to start and where to end in the world in 3D space. And then it will tell you what it hit along the way. So let's right click and type in line trace by channel. And we're going to hook the execution pin of the function into that. And we need to have the start and the end location. So the end location is the target, where to end the line trace. And that's actually where the crosshair is. And we figured that out back in our event graph. We'll furnish that when we call this function. We need to know where to start though. And we're going to start from the camera. Drag out the camera, and off the camera, we're going to get the world location. And that will be our starting point for the line trace. Now, the line trace is going to return a lot of information. So rather than return all that information, we're returning parts of it. What we're going to do is we're going to take the out hit structure and we're going to break that apart and only get the parts that we need. So if you drag out hit out and type in break hit result, you'll get a break hit result node. I'm going to expand that, and you can see all the information that you get from that. We'll use the return value to determine whether or not the line trace actually hit something. So put in a branch, hold down your B key and left click, and hook up the return value to this condition, and hook in the execution wire to the branch. So if we actually hit something, we're going to return this node, which is going to have all the information on the stuff that we hit, and the hit success variable or return value is going to be true. If we didn't hit something, the false pin will run. We're going to return that, and the hit success will be false. The information that we need is going to come from the hit result. So the location gets hooked up here, the normal gets hooked up here, and the block that was hit is going to be the hit actor, but we're going to cast it first to a BP base block just to be sure it was a BP base block that we hit. So drag off of the hit actor and type in cast to BP base block, and we're going to hook that into the true. And we need to re-hook that up there. And for the if that cast failed, if we didn't hit a BP base block but we hit something else, then that cast will fail, and that will go to our return node as well. So we have two possible returns. The nice thing is, now that we have a BP base block, we can return that as our output. You can close up the break hit result by clicking this up arrow, and we only have the nodes we need. And that's it. This function will determine whether or not we clicked on a block, and it will return the block that we clicked on. Let's compile and save, and then close the get clicked on block function. Back in the event graph, now that we have a get clicked on block function, we can drag off the exec pin from the timeline, type in get clicked on block, and call our function. Now we need to have a target. Where are we looking at that to find out where we clicked? And that is the crosshair location. So we're going to connect that from there to there, and that's quite a stretch. And you can use a reroute node to neaten that up by double-clicking on the wire, dragging that down, double-clicking, dragging that down, like so. So now that we've got a clicked on block, we need to check whether or not the hit was a success. We can hold down the B key for a branch, hook that up, hook in the hit success, and if it was successful, the true wire will run, and we're going to get the attach location of this block. So because this hit was a success, that means that we hit a BP base block, and we have a BP base block here. We can drag out of that and call its get attach location that we wrote quite a few modules back. We can pass in the location and the normal, the 2 bits of information that that function needs, hook up the true wire to that, and we'll have our attach location right here. Let's drag out our mesh of our character and play an animation. So we'll drag out the mesh and we'll type in play montage. And for the asset to play, select the block character interact quick montage. Change the play rate to 3, which looks better, it's quicker, and hook up the get attached location to that. When that montage blends out, we'll spawn the block. So on the on blend out, type in spawn actor from class, and we're going to choose the BP base block because we don't have specialized blocks yet. So we'll just start with a BP base block. And that's going to need to know where to spawn that actor. Right-click on the spawn transform and split that. And from the get attached location function, that returns the location of where to spawn that, hook that into the spawn transform location. Also, change the collision handling override to do not spawn so that it doesn't spawn a block on top of us if we're too close. Let's click compile. Let's click save and go back to the block game map and press play. You should be able to left click on the floor block and place blocks. And notice that animation playing when that occurs. You can also click on existing blocks that you added and place blocks, and they should spawn in the correct location. Additionally, note that the player will turn. So when I click to the side, the player rotates to the proper location where the block is. So to review, we created a custom event to place blocks. We applied world location and a forward vector to establish a beginning and ending location in 3D world space for the line trace. And finally, we created new instances of blocks at the correct location. We're well on our way to building a great block game. I'll see you in the next lesson.